So today what we're going to get into is some of the properties of fuel oil. So as a HVAC technician, 95% of the time it's probably going to be like an electrical related issue where a furnace isn't working right. But we do have to also keep in the back of our minds, oil and its flow from the oil tank to the burner. So knowing how oil is made up of and how it reacts during different temperatures and flows and stuff like that is another key to helping diagnose and maintaining an efficient type of furnace. So for oil, there's at least 6,000 products that are made up of petroleum. Approximately 5% of our electricity is generated by oil and oil-powered equipment. So some of the products that are made of petroleum is obviously we have gasoline. Gasoline does have petroleum in it. We have jet fuel, kerosene. Our home heating oil is made of petroleum, propane, lubricating oils, your waxes that we make, candles, and other waxes, asphalt on the roads, plastics, candy, believe it or not, has some petroleum products in it. If you ever read the ingredients on some of your favorite candies, you'll actually see that there are petroleum products on there. Crayons and CDs and DVDs are also made with petroleum products. Now, that's obviously just a few of what petroleum is used for. So, really, what is heating oil? Which is basically our main focus of this entire lesson. Well, heating oil is a fossil fuel. Okay, it comes from prehistoric plants, animals that form fossils. Other fossil fuels that we deal with in HVAC is natural gas. We deal with propane an awful lot, and obviously coal. Okay, we don't really see too much coal-fired boilers anymore, but there is coal that is still out there. Okay, fossil fuels are hydrocarbons. Okay, carbon is normally a solid, and if it's not totally burned, it's going to become smoke and soot. So when bonded together, your hydrocarbons can be a gas-like propane. It can be a liquid like heating oil, or it can be a solid like candle wax. So depending on the consistency of that fossil fuel and how it's refined and stuff like that, we can use it in different forms and for different things. Okay, hydrocarbon gases contain more hydrogen. The liquids and solids are going to contain more carbon. Okay, hydrogen, you think about it, it's like a liquid, like water. Carbon, it's more of a solid. So petroleum comes out of the ground in the form of crude oil and wet gas. That's how it's coming out of the ground. So both are a complex mix of compounds consisting of carbon and hydrogen. Sulfur and nitrogen are bound to some of these hydrocarbon compounds. So when we are taking them and we're putting them through the refinery process and distillation process, we actually take that carbon, that hydrogen, the sulfur, and nitrogen and separate it. We do that at the refinery. And when we do that through the refinery, it's through a distillation process. So basically what they're doing is they're taking that mixture and they're boiling it off at different ranges. Okay, hydrogen is going to boil off at a specific range. Carbon is going to, sulfur, nitrogen, all that stuff, we're going to take it and we're going to separate it. Okay, so your heating oil, diesel, jet fuel, kerosene are classified as middle distillates because their boiling range is in that middle of the sweep of petroleum products separated in that distillation process. We have roughly around 6 different types of fuel oils that are in use. You have your number 1, number 2, number 4, 5L, 5H, and number 6. All of these fuels vary greatly among one another, and only one is used in your residential and light commercial heating oil, and that is number 2. So really what we're going to be focusing on for this lesson is really just the number 2 fuel oil, because that's really what's the most common. Okay, so it is good to be aware of those other fuels, but you know, it's good to have a great amount of knowledge of them for most of your residential and light commercial work. So the properties of oil determines the grade and the reason a particular fuel is chosen for a specific application. Every one of those fuels that we've just mentioned, number 1, number 2, 4, 5L, 5H, and number 6, are all different types of fuel oils. They all have a different distillation quality. They all have different heat contents and sulfur and hydrogen contents and stuff like that, ash content. So we have to know the type of oil that we're dealing with so that we understand how that burner is supposed to operate. So fuel is broken down into different properties. You have your heating value. You're going to have a carbon and hydrogen content, a flash point, an ignition point, a pour point, a cloud point, viscosity, a water and sediment content, sulfur content, and its color. So heating values for most of our oil is going to range depending, again, now we look at all of these different oils that we just mentioned. For number 1 heating oil, it's going to have an approximate heating value of around maybe about 135,000 BTUs per gallon. Number 6 fuel oil is going to have approximately around 153,000 BTUs per gallon. Now you can see right there between those two numbers that the ranges in heating value is different. Number 1 actually is a lower heating value than number 6. Well, why is that? Well, that's just simply due to the fact of the refining process. Number 1 heating oil is a more refined oil. Number 6 oil is very, very dirty. It has a very high ash content. It's very heavy. So it's going to have a higher BTU content. Number 2 heating oil has a range of anywhere between 137 and 140 BTUs per gallon. But since we're dealing with number 2 fuel oil the most, when we do a lot of oil calculations and things like that, we usually just use the 140,000 BTUs per gallon. So for number 2 heating oil, we always want to say that number 2 fuel oil has 140,000 BTUs per gallon. That's the number that we use. That's the magic number. Flash point is the maximum temperature at which it can be easily stored and handled without serious fire hazard. So the flash point for number 1 and number 2 heating oil is 100 degrees. Okay. Now again, all oils, all liquid fuels are going to have a maximum safe storage and handling temperature. So when oil is heated to its flash point, what's going to happen is that some of that hydrogen is going to flash off. Okay, but the fuel will not really continue to burn. Okay, it's going to fly off and then it's kind of like going to die out. Hydrogen and carbon content, fuel oils are made of carbon and hydrogen. It's a chemical formula. It tells us the carbon and hydrogen relationship. For number 2 fuel oil, it's going to contain approximately 85% carbon and around 15% hydrogen. Okay, it's that carbon atoms that gives number 2 fuel oil and all the other fuel oils their BTUs and how much they can actually put off. The more carbon the oil contains, the more heating value it's going to contain. Okay, the carbon is what makes the oil heavy. Okay, the lighter that oil is, the less amount of BTUs it's going to be able to give off. The heavier it is, or the more carbon content it has, the more BTUs it's going to be able to give off. Okay, the higher number oils, like number 6, is going to have somewhere around 88% carbon. Okay, these oils are also called heavy oils because the weight is more than other oils. So number 2 fuel oil is going to have a weight of somewhere around 6.96 to 7.29 pounds per gallon. Number 6 weighs somewhere around 8.05 to about 8.44 pounds per gallon. And that's just simply due to that carbon content that's in there. Ignition point is the lowest temperature at which rapid combustion of a fuel will take place in air. It is the temperature at which all the fuel has been sufficiently heated and vaporized to the point where it continues to burn for at least 5 seconds. So number 2 heating oil has an ignition point of over 500 degrees. The pour point is the lowest temperature at which fuel will flow. Below this temperature, it turns to a waxy gel. Okay, number 2 fuel oil has a pour point temperature of about 17 degrees Fahrenheit, which means it can be used at lower temperatures and stored outside. Okay, additives or kerosene are added to heating oil during the winter to ensure that you have good flow. So additives is stuff that we can honestly put into your oil tank to help the oil flow easier. Okay, there's a lot of different ones that are out there that you can put in. You have a successful fuel treatment program, requires knowledge of the quality of the fuel in the tank and the specific service problems. Using additives off the shelf without testing may be harmful than doing nothing at all. So you got to really kind of do some research if you're going to add some sort of additives to an oil, if you're having a lot of pour point issues or flow issues. You have cold flow improvers that are out there. Flow improvers are basically designed to lower the cold temperature operability limit of the fuel and to avoid wax plugging of the oil filters. Pour point reducers or anti-gels lower the temperature at which fuel gels or solidifies, and cold filter plug point reducers lowers the temperature at which wax plugs the filter. So there's different ones that are out there. To dissolve wax, a solvent such as kerosene can be added to an oil tank to kind of help loosen up the oil a little bit. You got dispersants that are out there that you can put into. You have antioxidants and metal deactivators that also you can put in. You got biocides. You got all sorts of stuff that you can honestly just put into an oil tank to kind of help with the flow of oil. So viscosity is the thickness of the oil and its resistance to flow. Grease has a high viscosity. Gasoline has a low viscosity. Why? Because think about it, it flows easy. Okay? Heating oil viscosity is going to change depending on the temperature that it's in. Okay? So when we're thinking about viscosity, we got to remember as the temperature drops outside, the viscosity is going to increase. It's going to thicken up. And as it warms up, the viscosity is going to decrease. It's going to loosen up. It's going to become more of like a liquid. So normally, the temperature of oil in a basement tank is somewhere around 60 degrees. So at 60 degrees, usually the viscosity is good. It's going to flow usually with no issue. Now, if you have an oil tank that's outside and it's exposed to the cold elements, that tank is going to get really cold. So the viscosity of that oil is going to increase. And when that happens, it's going to thicken up. It makes it harder for the fuel pump to deliver the oil to the nozzle so that you have heat. Okay, so in the winter you might get an oil delivery of 5-degree oil. Okay, high viscosity will influence the performance of oil burners and how they react to things. Okay, as the oil starts to warm up and starts to flow, the viscosity is going to change, which is also going to change the performance of an oil burner. Okay, cold oil can cause a lot of different issues in oil heating. It can cause poor atomization of the oil through the nozzle. Okay, it could clog up a nozzle. Okay, it could cause delayed ignition. It can cause a noisy flame. It can make the boiler or furnace sound like it's rumbling off the floor. Okay, it's going to cause pulsation. You might hear the burner run, but it sounds like it's pulsating. Okay, it can also cause a lot of sooting on a oil burner. Okay, just think about viscosity. If it's a thick oil, it's not going to atomize very well, and you're going to have sooting and issues. Okay, viscosity is expressed in the Soyboat Universal Viscosity Seconds, which describes how much oil will drip through a calibrated hole at a certain temperature. And as that temperature drops on a certain oil, the thicker it will become, causing the oil to drip through the calibrated hole less and less. Carbon residue is a test that can be performed on an oil sample by vaporizing a known weight of the oil in a process in which oxygen is absent. The remaining carbon residue is then measured. So if the oil is being burned properly, it will not leave any carbon residue. Your cloud point is the temperature at which wax crystals begin to form in the oil. Cloud point is typically 10 to 20 degrees above the pour point of that oil. Wax crystals can clog oil filters and strainers. It can restrict the flow of fuel. Raising the temperature of the oil causes the crystals to go back into a solution. They'll kind of melt and just go mix right back into the oil. So the American Society for Testing and Materials, or better known as ASTM, does not list a specification for cloud point for heating oil, so that's going to change based on what type of oil you're dealing with and the temperature it's with. So both the pour point and cloud point are going to affect winter performance of a burner and could cause problems if the fuel is not properly treated. Okay, so like I said, sometimes you may have to add an additive to that fuel to help get the fuel to flow. Okay, a lot of things when it comes to doing the additives, again, is you got to define the problem in the additive that is needed. Okay, you got to first off figure out what the problem is first. Then you have to make sure that the fuel sample being tested represents the fuel being treated. Okay, with the additive, will the additive be used once, or is it going to be a continuous type of treatment that is going to be required? Does the additive perform more than one function? Okay, so sometimes if you put in the wrong additive, you can actually almost destroy or break down the oil, and then you're going to have even more issues. You have to obviously make sure that you're following the recommended treatment rates. You have to make sure that you're following all of your safety and handling instructions on the label and any safety material data sheets that should accompany with that sort of additive. So it's not just simply taking something and throwing it in an oil tank and calling it a day. You got to make sure that you're doing it correctly. Okay, so water in sediment content is the accumulation of water at the bottom of a tank, and obviously that is going to be undesirable. We want to keep water to a minimum when it comes to your oil tanks. Okay, it can lead to the formation of your sludge and ice. Okay, sludge is largely oil and water. However, water and oil usually do not mix. But if we add organic sediments to that fuel, it's going to act as a binder to stabilize that mix of fuel and water. And this will form like a milky white substance that will not burn. And that milky white substance is going to settle at the very bottom of the tank. So the ASTM limit for water is 0.1%. But most fuels sold has much less water in it. Okay, water can get into oil tanks and your oil lines simply through condensation. It can come in through leaks in your lines. It can come in from missing vent and fill caps. Corrosion can loosen and get lodged in strainers and filters, and in cold climates can freeze and block the flow of oil. When we are thinking about stuff like that, we want to try to keep, our oil lines from not getting frozen up. stuff like that. You want to make sure that, you know, if you have oil lines that are outside, you want to make sure that the oil lines are insulated and protected. We want to try to keep the oil lines from getting exposed too much to like cold elements. Okay, so sulfur content exists in varying degrees in all fossil fuels. Okay, the sulfur content of heating oil ranges anywhere between 0.5 to 0.05%. However, the ASTM maximum is 0.5%. So when sulfur burns, it mixes with oxygen and forms a sulfuric dioxide. It also creates a small amount of sulfur trioxide. So that sulfur trioxide reacts with water vapor in the combustion gases to create a sulfuric acid aerosol. And if the acid condensates or condenses at around 150 to maybe about 200 degrees, it will adhere to your heat exchangers, your fuel pipes, and inside the chimney. And it's going to create like a scaly, yellowish, reddish color looking type crust. And that's usually a bad thing. Okay, so scale makes up about 50% of deposits on the heat exchanger. It also degrades the efficiency of your furnace or boiler by 1 to maybe 4% over the year, which is why it's very important to have your annual maintenances done on oil-fired equipment, because that's where we go in and we clean it and we take the flue pipes apart, we look up the chimney and make sure that we don't have any scale and crap plugging up the chimney, because all that stuff is just going to make for a bad day and you're going to have problems over the end. Okay, that scale is going to block up your flue passages if you are not careful. It's going to restrict airflow. It's going to increase your smoke and soot. And if you really don't let it, and if you really don't get it taken care of, eventually, you know, the fire department is probably going to come out for a chimney fire. Okay, the color of your heating oil is nothing more than a dye. That dye is added to your heating oil to differentiate it from your on-road diesel fuel for simply tax compliance purposes. Okay, problems with fuel are not really necessarily indicated by the color of it, but if you have oil that has like a murky appearance to it, that may be an indication of a fuel quality issue. It could probably have some water or something that's actually in there.